Hello, it's Keith here, and this is lesson 38 of the platform-specific series of my 68000 assembly programming tutorials. And today we're going to be looking at the Genesis. We're going to be learning about the Genesis mouse. A little bit rare, but the Genesis could indeed support a mouse. We're going to learn about it today. Basically, the Genesis mouse will connect to one of the joystick ports. And basically, to configure it, we need to just use two ports, one to configure the port and the other to read and write data from the port. Now, what we actually need to do is we need to send a sequence of bytes, and then the mouse will return sequences in return. Some of these are a sort of initialization so that you can identify it's indeed a mouse connected to that port, and others are the actual data we want. Now, the port we will want to use will depend on if we are using a mouse connected to joystick port 1 or joystick port 2. And the example we're making today is this one here, which of course, as always, you can download from my website. Now, on this emulator, I'm using Fusion here. If I just press F12, I can use the mouse. I've got the mouse configured to joystick port 2 at the moment in this example, but this example will work fine from joystick port 1 as well. There's just a few lines of code you just need to rem out, and a few you need to unrem to enable the alternate port if you prefer. But basically, you can see we've got a cursor we can move around the screen, and you can see here from D0 to D3, I think it is, the data that is being read in the X and Y axis that has been read in by my code. So hopefully you've got something you could use to get started in your own programs. So what are the bytes we need to send, and what do we get back? So basically, you can see the sequences you need to send just here. This sent byte column is the bytes we would need to send. You can see it's essentially there's a hexadecimal 60 to start the sequence, and then it's 20 followed by 0, 20 followed by 0, 20 followed by 0, and then a 60 to end the sequence. So that's what we send. What we receive back, the grey bits here, are ones that are fixed. We don't necessarily need to look at those. I'm actually not checking them. If you wanted to ensure you were really connected to a mouse and not some weird freaky device, I suppose you would want to test these bits, but for today's simple example, I'm just sending the sequence and waiting until we get some valid data, and the valid data starts at this point here. So the first byte, all of the useful information is in the bottom nibble. So the first one has 2 bits, an X and a Y overflow, and this is if we move our mouse very quickly, we might move too fast, and the amount that the move is counted in units might be over 255. It's only a single byte for the X and Y direction, so if it's overflowed, those overflows will be set. We don't really need to worry about those. It would be a very large mouse movement that would cause that, so it's not something I'm doing anything with. Then what we've got is the sign bits here. Now, our X and Y axis go from 0 to 255. The mouse movement, the sign is actually held in a separate bit. So I suppose you could sort of think of this as a 9-bit sign number, if you will. So that's how it's done. There's a sign bit, and then there's the X and Y axis here, and they are a byte each, split into 2 parts because we only transfer a nibble each time. So that's the axes. That's the first nibble we get back of useful data. The next one is the buttons. Apparently you've got a start button. I've never actually seen a Genesis mouse. I don't own one, but apparently it has a start button. It's got a middle mouse, a left mouse, and a right mouse. So we've got 3 buttons there and this extra start button. And then what we've got is the actual movements. So we've got an X-axis movement here, and we have a high, that's wrong there, that should say high nibble and low nibble. I apologize for that. Let's get that fixed. Sorry, that's better. X-axis high nibble and X-axis low nibble. I got mixed up there, so used to working in high and low bytes. Anyway, so basically we get our X byte and our Y byte in 2 parts. We have to read them both in and combine them together. And then once we've got X and Y, that's the end of our data. And so we just need to send a final hex 60, and that's our transfer stop. And that's what we're going to do. So let's go over to the code. Let's see that in action. Okay, so here is our example here. Now, just in case you're having any trouble, I will show you how I've got things set up. If we go to set config here and controllers, you can see that I have port 2 set to a mouse. I'm setting the number 2 mouse here. I don't think you need to use the define option unless maybe for you defining the start key, but that's all you need to do up there, and then you just need to press F12 on the emulator and it captures the mouse. So there we go, that's how I've got this set up. But as I say, if you don't want to use joystick port 2 for your mouse, if you prefer to use joystick port 1, it's very easy to do so. All you need to do is change these lines, rem these lines out. These are the lines that are setting up joystick port 2 and loading the address of the data port for joystick port 2 into A0 here. So if you just rem those out, and then if you unrem these, that will enable joystick 1 for the mouse, and I have tested it does work with this emulator, so you can go ahead and do that. Now my thinking of using port 2 was that maybe I could write games that some use the mouse in port 2 and some use the joypad in port 1 and not have to reconfigure my emulator. But I did find a rather curious quirk. The game Mansion of Hidden Souls, the Mega CD game, which I've actually got for the Japanese system, I was playing it on an emulator just to get some practice in, and it wouldn't start. It kept locking on startup, and it seems to read joystick port 2 and get mighty confused about what's connected and just locks the game up. So I had to turn the mouse off before the game would work properly. So just something odd to bear in mind there if you try this example and then your emulator seems to stop working for the games. Maybe the mouse is playing things up. Okay. Now to start with, what we're doing is we're enabling these 2 bits here for output and the rest for input, and we write that to A1000B. That is the direction port for joyport pad 2, and then we're selecting the read port as port A1005 into A0, and that's what we're going to use in all these cases, and that's how we can convert this code easily in case we're using a different joystick port. So this example, basically we're going to use 4 registers as build-ups. We've got D0, D1, D2 and D3. D0 is going to be the X position, D1 is going to be the Y position, D2 is going to be the buttons, and D3 is going to be the overflow. Now I do use D4 in the code here as well, so that is going to be lost, but these are the ones that are used for returned data. Now, of course, there isn't more than a byte in these, so I'm not using all 32 bits, but the values will be returned in those registers. So we start by sending our 60 here, that's the initialization to start the sequence. We then send a 20, and we've got a couple of no-ops here just to delay to allow the mouse to respond. And then we send a 0, then a 20, and then a 0. Okay, so we read in our first byte here. And of course we only want 1 nibble. There's only 1 nibble of usable data each time that we get data back. So we're masking those bits and storing that in D3. We then send a hex 20 and we read in another byte and we mask in the bottom 4 bits because they're the only usable bit, and those will be the joystick, the mouse buttons, sorry, not joystick, I'm carried away. And then what we're doing here is we're sending another 0 here and we are reading in a byte. We're masking the bottom 4 bits. That is the top nibble, so we're rotating that left by 4 bits. That's the top 4 bits of our x-axis. We then send a hex 20 and we get another 4 bits, and those are the bottom 4, so we OR those with the other part of the x-axis. We send a 0 and we've got the top 4 bits of the y-axis, and then we send a 20 and we've got the bottom 4 bits, and we merge those together again. And so what this has done is it's given us some usable values in our registers that we can then process in the rest of our code. So if I press down, D1 is going negative there. If I press up, D1 is going positive. If I press left, D0 is going negative. If I press right, D0 is going positive there. And you can see the sign bits as well being set there. So there we go. So hopefully we've got something here we can make into a usable piece of code. And so just for a bit of fun, what I've done is I've ported the little mouse test routine that I did for my 8-bit systems, and I've made it work for the Genesis. And so what we're doing here is we are going to actually set a hardware sprite to an X and Y position, new pos X and new pos Y. Now these are actually 16-bit values, so we can have fractional pixel values, if you will, so that we can move half a pixel. So basically we're reading in a word, but we're ignoring the bottom byte, and so we're doing that by shifting to the right 8 bits here for the X and the Y axis, and we're just adding 128 here to move the sprite to the first visible hardware sprite position. And then the set sprite routine is using the hardware sprite code that I've used in my other examples. If you see the platform specific series and also the YQuest series, I've covered how to use hardware sprites before there. So what we're doing here is we are clearing the text cursor position, and that's just because we're using a monitor to show the raw dump of the data being read in by the mouse routine, and we're using this read mouse routine, which is what you just saw. What we're doing then is we're testing the sign bit here, and we are processing based on that sign. Now if the move is negative, then we're going to jump down to here. If the sign is positive, then what we're going to do is we're going to add the movement to the current position, we're multiplying it effectively by 256, because as I say, my coordinates are actually working from 0 to 32768 illogically in this code. That was actually originally for the Amstrad system, where we needed to move in half bytes. Basically, it was a convenience for that system. So then we're comparing to the maximum width of the screen here, and if we've overflowed, we don't store the new value, but if we're okay, we store the new value for the mouse position there, and that's what we're doing. And then here is the negative version, and we're sign extending the byte into a full 32-bit value so that we can do an add long here. And that will allow us to move our coordinate accordingly. Again, we're just testing if we've actually rolled over there, if we've gone below 0. And so we're just updating our X position there. We're doing something pretty similar for the Y position. Now, the only quirk is the Y position is actually, the axis is actually inverted. It was going up the screen when I wanted it to go down the screen. So we are actually negating it there, and we're flipping the check of the negative bit there for the sign bit. But apart from that, it's all the same. I'm going to say it's not really a serious example of how to use the mouse, this bit here. It was just something to show a practical example of the mouse being processed. Unfortunately, I'm not planning on porting my Suck Hunt game to the 68000 systems, because it took too long to it takes too long to port to new systems, unfortunately, so I'm not planning on doing that. But if I had done that, this would have been the basis of it, because it's basically using the same internal logic and it's using even the same sprite. So that's why I've ported this particular example. Now, as I always say, if you like what you've seen, you can go to my website, download the source code and have a play with it, and hopefully you can make something better than I can out of it. That's the plan. So go and check that out. If you liked what you saw, please hit the like button and subscribe. It really helps me out when people do that. It helps because YouTube recommends the videos to more people, and also if you want to support my content, you can buy t-shirts from my Teespring store. I've got a Suck Hunt t-shirt here, and you can also buy my book, Learn Multi-Platform Assembly with GB Ackermans, from Amazon now. It covers Z80, 6502, 68000, 8086 and ARM, as you probably know if you've watched these videos before. But it really helps me out if people buy the books, because it helps fund me spending stupid amounts of time doing all this kind of thing. Anyway, I hope you've enjoyed today. Thanks for watching, and goodbye.